$50 billion.
Yeah. Yeah.
That is the number. The number that's been floating around every tech newsroom this week. It's so big, it almost feels abstract.
It definitely sucks all the oxygen out of the room. When you see a number with that many zeros, it's hard to focus on anything else.
Right. And that is exactly my problem with it.
Yeah.
Everyone's just staring at the checkbook, obsessing over the whole corporate drama.
Between Amazon, Microsoft, OpenAI, yeah.
But I spent the weekend looking at the actual engineering logs from AWS, specifically the updates from January 26th to February 2nd. And the real story there isn't about writing checks. It's about plumbing.
Plumbing is unsexy, but it's usually where the actual history gets made.
I'd argue this week was a tipping point. We're seeing a shift where, well, we're just done with the chatbot phase. We aren't building toys anymore. We're seeing the industrialization of AI agents. Moving from, look at this cool demo to this thing is an employee that shows up at 9 a.m. and remembers what it did yesterday.
That is the right lens to view this through. If you look at the Bedrock updates, the memory, the governance, the chips, it's all about creating autonomous agents that are, well, boringly reliable.
And for enterprise, boring is the holy grail.
Exactly.
So welcome to the deep dive. We are looking exclusively at the AWS Bedrock ecosystem for late January 2026. And our mission today is to figure out if these new AI employees are actually ready for work or if this is just more hype disguised as infrastructure.
Let's look at the evidence.
Okay, I want to start with the brains of the operation, the core intelligence. Usually we just talk about a new model release, but this week AWS dropped something called reinforcement fine-tuning, or RFT, for their Nova models. Now, I know what fine-tuning is. You train the model on your data. But why do we need reinforcement fine-tuning? Is the model not listening?
Well, think of it this way. Standard fine-tuning it's like instruction tuning. You're giving a new employee a manual. You show them an input, you show them the correct output, and you say, copy this style.
So it's rote memorization.
It is.
Here's the form. Fill it out exactly like this example.
Right. But that has limits. RFT is different. It introduces a reward model. It's less like a manual and more like a coach standing over your shoulder. The model generates a few attempts at an answer, and the reward model grades them. It says, this attempt is good because it's concise, or this attempt is bad because you rambled.
So instead of just memorizing the answer, it's optimizing for a specific behavior or a quality.
Precisely. And that distinction is massive for performance. According to the AWS blog from January 27th, early findings show RFT delivering a 66% accuracy gain over base models on specific tasks.
66%. That's not a small bump. That is the difference between a prototype you show your boss and a product you actually ship to customers.
It bridges the gap. It allows enterprises to take a generic model and force it to align with very specific, nuanced objectives like be extremely terse or always prioritize safety without having to build a new model from scratch.
Speaking of models, Bedrock also kind of opened the floodgates on open source models this week. They added, 18 new open weight models?
They did, yeah. We're talking models from Google, Mistral AI, Minimax AI.
Hold on. Google models on AWS. I thought those two companies were in a blood feud for cloud dominance. Why would Amazon let Google models onto their platform?
It does seem counterintuitive, doesn't it? But this is Bedrock's neutral hub strategy in action. Amazon is betting that developers don't want to be locked into one brain. Maybe the Google model is better for translation, but the Claude model is better for coding.
And Amazon doesn't care which one you use, as long as you're paying them for the compute to run it.
Exactly. And for the developer, it solves a huge headache. Running these open source models yourself is an operational nightmare. You have to manage the GPUs, the scaling, the uptime.
Right.
Bedrock is saying, we don't care whose brain you use, we'll host it. You just run it.
It's the Swiss Army knife approach.
Okay.
But okay, having a smart brain is great. But if that brain has the memory of a goldfish, you're limited. This brings us to the part of the notes that I found most interesting, what you call the agentic shift.
This is where the landscape really changed this week.
It starts with something that sounds incredibly boring. 1 hour prompt caching. When I see caching, I just think of clearing my browser history. Why is this a headline feature for AI?
It sounds mundane, but you have to understand the economics of these AI agents. Let's say you have a coding agent. To do its job, it needs to read your entire code base, thousands of files. That's a massive prompt.
Which costs money to process every single time you send it.
Huge money and time. Previously, the memory of that code base would expire after just 5 minutes of inactivity.
5 minutes. So if the agent pauses to say, run the code it just wrote?
And that code takes 6 minutes to compile and run. When the agent comes back, the cache is gone. It has to reread the entire code base all over again.
That is incredibly inefficient.
Yeah.
It basically means you can't have an agent that thinks slowly or waits for anything.
It killed slow-thinking architectures. But as of January 26th, for the Anthropic Claude 4.5 models, that default time to live is now 1 hour.
So the agent can actually take a coffee break.
It can wait for a human to approve a plan. It can wait for a long database query. It enables these long-running asynchronous workflows without burning a hole in your wallet.
It transforms the agent from a chatbot that needs instant replies into a worker that can handle a task over an entire afternoon.
That's it.
That makes sense. But for an agent to be an employee, it needs hands. It needs to actually click things. I saw an update about server-side custom tools. How is that different from how we were doing it before?
Before this update on January 29th, the hands were attached to the client, your laptop or your specific app server. The AI would say, I want to search the database, and it would send that request back to you.
So I'm the middleman.
You are the bottleneck and a security risk. If your laptop disconnects or the client app crashes, the agent fails. With server-side custom tools, Bedrock can invoke AWS Lambda functions directly. The AI is inside the cloud, executing code, updating databases, and calling APIs without ever talking back to the client.
So it removes the latency and keeps everything inside the firewalls?
Correct. It's a massive step toward true autonomy. The agent isn't asking you to do the work, it is doing the work itself.
Okay, but here's the one that actually scared me a little. AgentCore Episodic Memory. We're getting perilously close to sci-fi territory here. You called this the Westworld update in the pre-show notes.
I did, and I stand by it.
Break it down for me. What does it actually remember? Because chatbots have had memory before. They can recall what I said 2 minutes ago.
That's just context window, not episodic memory. Before this, chatbots were essentially stateless between sessions. Every time you opened a new window, it was a blank slate. It didn't know you. It didn't know what you did yesterday.
Okay.
Episodic memory changes the physics of that relationship.
So it remembers my name.
Much more than that. Announced around January 26th, AgentCore introduced a capability where agents store structured summaries of their turns. They recorded the situation, intent, action, thought, and assessment.
Assessment. So it remembers if it did a good job or not.
Yes. And this is what enables cross-episodic reflection.
That sounds like therapy for robots.
In a way, it is self-improvement. It means the agent can look back at past failures. So if it tried to solve a coding bug yesterday using method A and it crashed the system,
Right.
When you ask it to solve a similar bug today, it remembers. Method A failed. I should try method B.
Without me having to tell it.
Without you saying a word. And crucially, without retraining the model, it's accumulating experience.
That actually changes the value proposition entirely.
Yeah.
That's the difference between a tool and a colleague. A tool you have to operate. A colleague learns how you work.
Precisely. If your AI employee remembers that you hate pie charts and prefer bar graphs, or that the staging server is always flaky on Tuesdays, that is institutional knowledge being built inside a machine.
And that knowledge stays even if the employee quits. Well, I guess the AI can't quit.
Not yet.
Let's not give them ideas.
Yeah.
But all this thinking and remembering requires power, physical electricity and silicon. I know AWS announced new chips, but do we really need more power just to run a smarter chatbot?
We absolutely do. On January 26, AWS announced the general availability of the EC2 G7e instances. These are powered by the NVIDIA RTX PRO $6,000.
The Blackwell architecture, right?
Specifically using the Blackwell architecture, yes. This is the new heavy hitter everyone has been waiting for.
It is.
And the E in G7e stands for efficiency, but really it's about throughput. These instances deliver up to 2.3 times the inference performance of the previous generation.
Why the massive jump? Is it just so the text appears on the screen faster?
It's for complexity. Remember those agentic loops we just talked about? The memory, the reflection, the tool use? That requires the model to run through the neural network multiple times for a single task.
So if you don't have faster chips, that smart agent with the episodic memory is going to be agonizingly slow.
Exactly. The hardware has to scale with the software's ambition. And it's not just what chips you use, but where they are. There was a quiet but huge update for South Africa this week.
The Cape Town update. Global inference.
Right. This solves the latency sovereignty trade-off. If you're a bank in Johannesburg, you want to use the best model Claude 4.5. But that model might physically sit in a data center in Virginia or Ireland.
So you have to send your customers' financial data across the Atlantic.
Which introduces latency, but more importantly, a lot of legal headaches around data sovereignty. So what AWS did was set up a local endpoint, a front door in Cape Town.
Great.
You knock on the door locally, AWS handles the secure routing to the global compute and sends the answer back.
So it feels local, even if the brain is global.
And it ensures resilience. If the cable to Europe gets cut, the system can reroute. It's vital for African enterprises wanting to play in the big leagues of AI without breaking local laws.
Okay, so we have super smart agents, they have memory, they have hands, and they're running on super fast chips globally.
Yeah.
This sounds like, well, a recipe for chaos if we aren't careful. How do we stop these agents from, I don't know, casually leaking trade secrets?
Governance. It's the unsexy hero of the week. On January 27th, AWS Network Firewall added GenAI web category filtering.
That sounds like parental controls.
It is parental controls for your engineers. It tackles shadow AI.
Shadow AI sounds ominous.
It's a massive problem. Shadow AI is when your developer gets frustrated with the internal tools and secretly pastes your proprietary code into some random public chatbot to get a quick answer.
Leaking IP to the public internet because they were in a hurry.
Exactly. This new feature lets security teams inspect the network traffic and say, block all traffic to unapproved AI sites. You can whitelist Bedrock and block everything else at the firewall level.
Brutal, but probably necessary. And for the folks who are really paranoid, or I should say regulated, there was that EU sovereign cloud update.
The cloud within a cloud?
This is the facility in Brandenburg, Germany.
Yes. And the key here isn't just that the servers are in Germany, it's that the people are in the EU. It's operated exclusively by EU residents and citizens.
Why does the passport of the engineer matter?
Because of things like the U.S. Cloud Act, there's always this fear in Europe that if a U.S. company operates the server, the U.S. government can subpoena the data regardless of where that server sits.
Right.
By having it operationally separate, AWS is giving a guarantee to, say, the German public sector. Your data never leaves the EU, and no non-EU eyes ever see it.
That's a massive selling point for governments. One last piece on the control side. We talked about blocking bad AI, but what about watching the good AI? You mentioned a partner called Ground Cover.
Ground Cover. They introduced eBPF support for Bedrock on January 28th.
eBPF. I always see this acronym and my eyes just glaze over. Why does a manager need to care about kernel-level monitoring?
Hey, think of it as an X-ray for the Linux kernel. Usually to monitor an AI application, you have to add code to it. You have to instrument it. You stick probes in the code to say, log this data.
Which slows it down and breaks things. And if you didn't write the code, like if you're using a closed model, you can't even do it.
Right. eBPF sits at the kernel level, the operating system level, and watches the memory and function calls without touching the application code. Ground Cover is using this to trace the reasoning path of the agent.
So you can see why the agent made a particular decision.
You can see the logic flow, the latency of each thought, the token count all without modifying your agent's code. It's zero instrumentation observability.
That's wild. It's like hooking a lie detector up to the employee without them knowing.
Let's call it a performance monitor, but
Yeah.
yes, it gives you visibility into the black box.
Let's pivot to the finale. We've talked about the tech. Who is actually making money with this?
Yep.
We're saving money. Because all these features, memory, caching, chips, they cost money to implement.
We have to talk about that $50 billion rumor again.
We teased it at the top. Amazon investing up to $50 billion in OpenAI.
The reporting from Bloomberg and CNBC suggests it's likely a chips for equity deal.
Which means Amazon isn't just writing a check. They're giving OpenAI access to their custom silicon tranium and inferentia.
And that is the strategic masterstroke. OpenAI has been married to Microsoft and NVIDIA if they start training GPT-5 or GPT-6 on AWS chips.
It validates AWS silicon as a true rival to NVIDIA.
Exactly. It breaks the monopoly. It tells the world, you don't need NVIDIA H100s to build the best models. You can use AWS Trainium. That validation is worth more to Amazon than the equity.
It's 4D chess.
Yeah.
But while billionaires play chess, regular companies are trying to ship products. You found a case study from Pushpay.
Pushpay. They do management software for churches and charities. Not exactly a massive tech giant, but they solved a problem that plagues everyone. They built a search agent using Bedrock and Claude Sonnet 4.5.
And the numbers.
They improved search accuracy from a plateau of around 60% up to 95%. That's nearly perfect. How did they do that? Did they just use a better model?
No, and that is the key. They stopped guessing. They built a golden data set, a list of perfect questions and answers, and they relentlessly tested the AI against it using automated evaluations.
So they graded the homework.
Rigorously. And the result wasn't just accuracy. They reduced time to insight from 120 seconds down to 4 seconds.
2 minutes to 4 seconds. That changes user behavior. Nobody waits 2 minutes for a search bar. Everyone waits 4 seconds.
It proves that the barrier to entry isn't magic. It's just rigorous testing. And then there's Totogi in the telecom space.
Telecom billing. The most complex, boring software on Earth.
It is. Changing a billing plan usually takes a week of engineering time. Totogi used a multi-agent framework on Bedrock to automate it.
Yeah.
They got it down from 7 days to just a few hours.
7 days to hours. That is an insane productivity gain.
And here's the kicker. The AI generated tests with 76% code coverage. So it wasn't just writing code fast, it was verifying its own work. That brings us full circle to the industrialization theme. We have agents that remember via episodic memory, that have hands via server-side tools, that run on fast G7E chips, and that check their own work.
It's no longer about chatting. It's about workflow automation.
So as we wrap up, what's the one thing you want the listener to take away from this week? What's the signal in all of the noise?
It has to be the episodic memory. I want you to really think about the implications of that. We are moving from a world where software is stateless, where it resets every time you turn it off, to a world where software accumulates experience.
Like a human.
Like a human. If your AI employee gets better at its job simply by doing it, if it learns your quirks, your code base's weirdness, and your customers' preferences over time, then the value of that AI isn't just the code, it's the tenure.
You're building institutional knowledge inside a neural network.
Exactly. And that asset becomes incredibly valuable and incredibly hard to replace. You can copy code, you can't copy experience.
A fascinating and honestly a slightly terrifying thought to end on. We'll be watching to see if that $50 billion deal actually lands and if these agents start asking for a salary. See you in the next deep dive.